So in our video, we're going to take you through a project that we like to do at our school. It's all about catapults. So at the end, we'll have some sort of fusion model or other CAD model. We'll go ahead and I'll take you through the presentation that we go through in class. We always start each class with some daily questions just to kind of help guide us through our processes. And we go through some of the frequently asked questions about, we're going to make some sketches. We're going to go through our typical design process. So we're going to make sketches. We're going to see how close we can get, to our original idea. And we're also going to see the evolution of the idea, right? And we talk about project flow. We want to make sure that we know the sizes of the material we have to work with. So we're actually going to build this project. Okay, so we'll go back to our wood shop, build these things out of wood. Heck, we may even use our 3D printers and do it that way. All right. And then we also need to know about just different sizes. Our CAD model may come up with, hey, we need it to be this tall. But when we go to the back and we try to build that, remember that design for manufacturing and assembly, we don't have that availability, right? So we would say something like 8.5. That's a manageable thing we can make. And then we also need to talk about our capabilities of the machines themselves, right? Can we make some of the cuts we need to make? All right. And then, of course, our main point of the project is, does the geometry we use in our CAD, does it actually work well for the build that we're getting ready to make? So we move in and we talk about the catapult constraints. So these are things that we've all agreed on. In our room, we have this little box, and the catapult has to fit in the box. And it basically comes down to, this was a box that Amazon delivered something to me, and we had to make sure it all fit in there. It's a pretty easy test that when we go on test day, we can see quickly. All right, so you can see 10 rubber bands, 3 hooks, and there's a picture of the hook. You can get those at Menards or Lowe's, or any standard hook will do. Then we also have to have a way to anchor it down. At the beginning, when we first started this project, we had a lot of slingshots. It was kind of unfair because you could get some of your arm motion involved in it. So we decided we would just strictly go with an old catapult. Right? And we set some goals here too. We want to be able to launch at least 20 feet. It needs to be able to do it 5 times without breaking, and has to have at least 5 components drawn in CAD. And then we talked about, these are the things that you're going to submit. These are the things you're going to turn in. So dimension drawings, hand sketches, assembly view, exploded view with bill of materials, a slide with a table in it that made different distances that you recorded. And also, we always like to do this one, slide with an additional test that you created. There's lots of different ways to do that. Some people do like an accuracy test, like they launch 5 times and they try to hit the same spot every time. Some people do like a force test where they build like a wall of just scrap wood, and the ball has to go through there. Pretty neat stuff. Let's talk about this ball, by the way. The ball I get off Amazon, it looks just like this. Just a foam golf ball. We used to use ping pong balls, but they just didn't fly far enough. They didn't have enough weight to them. We can't use a real golf ball because that can do some damage. So you can see the whole bag. You can get 16 of them for about $10. They're pretty good, and they last a while. They're pretty good. Here's an idea I made in Fusion. Just one test. Okay, so you can see everybody should have this in their presentation, right? There's a catapult, there's an exploded view with the bill of materials. That should be in everybody's presentation at some point, right? Then we went in here. This is one I actually modeled in Inventor. See a little more complete with the exploded view, bill of materials, and then even an assembly view. And in our assembly views, all we're trying to do is, if this were a trophy, we want to make sure it can fit in the trophy case. So that's all we're doing with the dimensioning there. So you can see that's not crazy involved. Here is the grading, so you can click there and you can get a rubric as well. Okay, so you can see how you're going to be graded. And then here are some examples, that we've taken from the past, and you're welcome to click on that. And this is just kind of nice because you can go here and you can kind of see what's expected in the presentations. So you can see they go through their dimension drawings, They talk about their adjustments and evaluation, and we're really big on that because this project will change, right? It's going to evolve like most projects do. And then your distances, and then they came up with their additional test. Right? So you can see that, and I left you a few examples in there of just pretty solid presentations. Let's go ahead and get started in Fusion. So we're going to try to do something like this. So the very first thing I'm going to do is I'm going to come over here and I'm going to say new folder, and I'm going to name it. So for me, I'm just going to call it tutorial catapult. Okay, so every bit of magic is going to happen in that folder. I'm going to go over here now and say new. Notice I'm in that tutorial. The very first thing I want to do with anything I ever do in Fusion is I want to get a new component. And I think I'll call this the base. I like to use all caps because it helps me see it easier. So now I'm going to come in here and I'm going to pick a plane, and I'm going to make the base be a manageable dimension. So remember, I've got a box that this thing has to fit in, right? So let's take a look at that. Let's go back on this slide. We want to see those constraints. So look, it's got to fit in this size box, right? That's important stuff. So I want to make sure that I do that when I'm designing. So I've already drawn this. Let's see here. I think I'm going to keep this around 8. And if I look at most of the boards that I have, I notice that I don't really have anything that goes over 8 inches wide. So I think what I'm going to do is just kind of trim this thing down to be about 5 inches. So there's my base. Now I've noticed also, because I looked at all these materials before I went back here, I noticed that almost everything is 3/4. Right? So I can either enter it as a fraction like that, right? I can enter it as a fraction, or I could just put 0.75. I'm going to get the same results, right? So now if I rotate this thing around, I see that there's the base. All right, next up, I'm going to go up here, right? And I'm going to click on this because I want the whole assembly. I think before I get going too far, and honestly I probably should have started this way. I should save it, shouldn't I? So I'm going to just call it catapult. Now I'm going to start a new component. I think I'm going to call these the uprights. Okay, so I'll come back in here now and I'm going to start drawing on top of that. I'll just take a basic rectangle here. I'm going to leave that top number alone, but I am going to make this number over here. I'm going to make that be the 3/4. Alright, so I'm going to see here. Let's see, I'm going to dimension from this line to the edge of that board. I can make that 2.5. And then let's make this 2.5. So 2.5. I'll go ahead and extrude that up. Well, let's see, how tall do we want this thing to be? There's 4 inches, but remember, there's 3/4 down there as well. Okay, so maybe I'll make it 5.25. Because if I add the 3/4 down here, that makes it 6, right? And that's well within our range there. Let's see what else. You know what I need to do while I'm here? I need to go ahead and put an axle hole in. Now the axle hole is going to depend on what size dowel rods we have, right? So 0.486, that's not even a thing. I know we have some 1/2 inch dowel rods, so I'm just going to put 0.5. And then I am going to kind of locate this thing. I'm going to say from here to here, because I need to know where to put the drill bit, right? Let's use some pretty numbers. So let's make that maybe a 1. From side to side, I already kind of located it with the midpoint. So it should be 1.5. And I'll go ahead and cut this thing out because it's supposed to be a hole. So there it goes. And I tell you what, while I'm here, I'm going to make a spot for this stopper to be. Remember, we have to have some sort of way to stop this thing. And I know again that it's 3/4, so I'll probably just use 3/4. And I don't know if you don't have your grid up, man, you really need to get that going because that thing's quite helpful, isn't it? So there it is. I'm going to cut both of these back at the same time. Alright, So now I've got my upright piece, and I'm comfortable with that. Okay, so now I'm going to go back up here to the entire catapult and select everything. Now these things are moving right now. I just drew it in place, but they're actually not jointed. So I am going to go ahead and joint. So I'll say, alright, give me the bottom of that. And give me the edge. See how that's flat? And then I'll scoot that on there. And it looks like I'm probably going to say 0.375. That's half of 0.75. Alright, now I'll take this same piece. I'm going to right click on it and copy it. Then I'll come over here on my screen anywhere and I'll right click and say paste. And there's paste. Now it puts it in the exact same spot, but that's okay. I just move it because it doesn't really matter. It's not jointed yet, right? I need to joint the thing. So here's the joint. Come in here now. And I'm just going to put it on the opposite side. And I'm probably going to have to use my offset again, right? So there's 0.375. Okay, so I'm going to go here. And I'm going to start a new component. And I'm going to call it axle. And there it is. I hit OK. I'm going to hit sketch. And I'm going to come to this outside. And then I'm just going to draw a circle right here. I don't really need to do this. I could just use this circle. I'm going to hit E for extrude, and I'll click it, and I'm just going to make it go. I'm going to drag that arrow all the way through, and I believe we made it 5 inches, right? So this should end up being, what, a -5 probably? Yeah, there you go, -5. Alright, so I've got an axle created. I'm going to go back out here, get to the entire assembly. Now remember, that's not jointed just yet. So I'm going to go over here to joints. Click there and click here. Now remember, here's the flip button. Just in case it gets all goofy on me, I can hit flip. It may come in like that to begin with. I'm going to go ahead and create the lever now. So make sure I've got catapult selected. Hit new component. And I'll call this the lever. So I'm going to just start on that circle again. So I know that the circle has to match up, right? So there's the circle. Now I'm going to come over here. I've chosen a rectangle. And what I'm going to do is just kind of draw a rectangle here. I haven't really decided on lengths yet. But I know that this is going to be 3/4 thick. So I'm going to say from the center to this edge, 375. Sorry. Same thing here. 0.375. Now I just need to decide the length here. So I'm going to say from the center here, I don't know, let's make that like a 3. And I think I want it to be longer up here. So let's make that like a 4. Maybe even a little larger. I'm going to make it a 4.5. Okay, now I'll extrude it. Now remember, make it an extrudable distance here. So let's say, I'm going to make it like 1.5. Yeah. And I'll hit OK. Now I'll go back up here to the catapult and let's put this lever in place. So I'm going to use joint. And then I'm going to take this circle here. And I'll put it on the axle. Obviously it doesn't go there, right? So I'm going to use my offsets and kind of center that thing up a little bit. Now on this particular constraint, everything has been joint up until this point, or excuse me, everything has been rigid, but I need this to be revolute. I need it to spin a little bit. It won't spin. You know what? I need to ground something, don't I? So here's the base. I'm going to just right click on base and say ground. So now this thing should spin. Everything else stays in spots. So we've got an issue here. You know, one very important thing that we didn't talk about. We're designing this for a ball, right? So I think what we need to do is we need to make sure we have the dimensions of the golf ball. And what you're going to find is that golf ball has a diameter of, it's like 1.68. So I think what we'll do is I'll go ahead and I'll just start a new component again. And I'll just call this the ball. Alright, so I'll start a new sketch, and I'm just going to put the ball up here somewhere. So I don't really want to attach this thing yet. I do mine, and I'll set a circle here, and I'll say the diameter is supposed to be 1.68. Then I'll just take a line, and I'll draw a line across. I'll finish the sketch, and then I'll just do a revolve on it. So profile, pick whatever half, it doesn't matter. And then axis, pick that line in the middle. And now I have a golf ball, or at least have the right size in there. Okay, so I'll go back up here to catapult. Now the golf ball can move around still, but that helps us decide, you know, all right, how should this thing lay out? So that'll help us out a bit. Now some things that I'll also give, I know we're going to have some cups in the classroom. So I think what I'll do is I'll make a cup. So you need to get the measurements of that cup, but I'm going to start another new component here. And I think I'll call this just a cup. So I'll probably follow a similar result. There's several ways to make a cup. I think I'm just going to keep mine simple here and just do another kind of like a revolve here. So I'm going to use a line this time. Our cup, let's say it measures, I think it's like 1 3/4 inches tall. And it comes out, I think the base of it is a 1-inch circle. So it's going to be a 0.5 there. Then I'm just going to come up. I know that the top of it, and this is where I'm going to have to, see I just drew an angled line because I knew it does something like that. But I'm going to draw a line that connects these two now. And that, the radius at the top, make the radius here a 1-inch radius. All right, so essentially I've drawn half the cup, right? Now I'll hit finish sketch, and then I'm going to go up to revolve. And I'm just going to revolve around the axle, or the axis rather. And then from here I'm just going to do a simple shell. I make it like a 0.1. It would probably be much thinner. It's probably going to be more like a 0.05 because it is a paper cup. Alright, so I've got some constraining to do, or some jointing to do. So I'm going to go back to the whole entire assembly. And I'm going to use a joint here. Get these things out of the way. So there's a joint. I'm going to joint the bottom of the cup to the axle. I need to slide that down. I don't know if you've noticed, but it's still in a revolute type of joint. So for motion, I'll just go over and change that. That needs to be rigid again. So now if we pull it back and spin it, everything works. Let's talk about this ball. Let's go ahead and joint that thing too. So I'm going to click that and the cup itself and just kind of place it in there. Motion wise, it can rigid's fine. I want to make sure that it fits in there. That looks good. Alright, so one of the issues that we also are running into here, for a catapult to work, it needs to be stopped. So let me take this to the front here. And let's kind of place this so we can see it. So this is going to come down, but not, right now nothing is actually stopping it. So it would just continue to swing, you know, down like so. And this is one of the reasons we model things in CAD. So I'm going to draw a stopper. And I think what I'll do is just call it the stopper bar. And then I'll come over here to the side of one of the uprights, because I'm going to use that geometry that's already there. Just come up here and draw us a square. And then I'll extrude it across. It's very similar to the axle, right? So that's also going to be what, a -5, just the way I drew it. Then I'll come back up to the entire catapult. There it is. I'll go ahead and joint this thing up. So now I can really truly test the thing. I want to make sure everything is going to fit, right? Because if I look in there right now, we're almost making contact. So I'm bringing that up until we actually do make contact. So I'm going to keep bringing it. Notice I've got it. It's going to probably start here, right? Or actually, I'm going to pull it back until it hits. So I'm not going to get much pullback. And then I'm going to let it go, and it's going to be able to go all the way up until it hits that bar. So I've got quite a bit of distance here. Actually, it's going to hit right there, isn't it? So it may be that I want to take this piece and move it back here. Alright, so I'm just going to go up here to my last joint that I put in, right there. I'm going to delete it. And I just kind of, all I want to do is just kind of scooch it over here for now. You can see that I'll be able to pull back on that, won't I? Because the rubber bands are going to be here. That'll give me a lot of potential energy, right? And then when I let it go, though, it's going to come up and hit right there. I don't know that that's much better either, is it? Okay, but what I can do is I can add some changes back here. I can change the angle of this catapult. Right? Instead of it hitting right there, maybe I take this and kind of turn it. Oh, that's a little extreme. But I could actually put a piece of wedging under here, and that changes the angle on that thing. Again, all a part of CAD. All a part of the CAD model. I'm going to go ahead and throw that piece back in there so that it's put together at least. But you can see that this allows us to kind of see how things are actually going to operate. Maybe I want some braces here. If I want to go ahead and put those in, I will go up here to New Component. And I'm just going to put like angle brace. And from here, I think I'll just I'll click sketch mode. And I'm going to go on that side. And I believe I can just take a line and kind of connect the thing. Probably going to go straight to that corner. Now that corner's not hanging and playing nice, so what I'm going to do is hit escape. I'm going to go up to create and say project. Notice the shortcut key is a P. So I can say I want that geometry and I want that geometry. So I'm going to go over here on project and say okay. Now I'll take that line tool and I can go, look at that, that corner just plays real nice now, doesn't it? So I will make this triangle kind of nice to work with. So this number here, from here to here, that's a 2.5. That's doable. So from this point to this point, if I look at that, that's 2.17. Good night. I'm just going to put 2.5. Make those sides even. So I'll extrude that now. Pick this side, and I'll just make it go back, what, negative 0.75. Now then I could come back here to the whole thing. So that, in a nutshell, is how you create the catapult.